All right, I'm going to kick things off. So welcome to day 2 of Data Driven 23. I hope you all enjoyed day 1 as much as I have. So this is an online conference, as you all know. So I feel a little bit more well-rested than I do at offline conferences. So thanks for tuning into this one. We're going to dig into the economics of an Oracle network and market data in general. In order to do this, I'm going to zip through a bunch of background slides, which may be redundant to some of you, but they're going to set the stage for how Pyth is set up and sort of how market data works in general. Okay, cool. So let's hop in. So I'll talk a little bit about what an Oracle is. So blockchains are state machines. So it's a distributed group of nodes. They maintain the state at every block. Right? The simplest form of state is who owns what now. Applications and smart contracts are then built on top of the state, which changes the who owns what based on a set of criteria. Okay, so it would be a pretty limited design space if the applications were limited to just the state data. But luckily, that's not the case. So external data can be brought in to the environment to enrich the decision criteria to make interesting applications. Given the potential for the value to be transferred, that data needs to be trustworthy. So this is what oracles do. They update the state with exogenous data so that developers can build interesting applications. The very first Oracle networks were designed to optimize for trust. Unfortunately, they did so at the expense of speed. So this brings us to Pyth's raison d'etre, the reason for being. The thesis is that high throughput DeFi needs trustworthy, fast oracles. Right? So fast or low latency is the unique part of this. I'm going to walk you through an example to try and illustrate why this is in fact the case. So this chart shows you, this was actually a part of the SIP proposal that Synthetics was using for, or that we were using at Pyth to propose Synthetics use Pyth as their oracle for the new Perps product. And I bring it up here because I think it highlights why speed is important. In any of these areas where there's a big gap, so you see there's a red line, this is the chain link price that they were using, they were publishing onto Optimism. There's the centralized exchange price in white, and then there's the Pyth price in purple. So every time you see there's a big gap between where the purple and the white line is and where the red line is. That means that the passive liquidity has not yet been updated if that is being used as the oracle. Passive liquidity would then be adversely selected. This is the TradFi code word for losing money. In crypto, we tend to refer to this as impermanent loss, but it's basically a way to programmatically ensure that you will not make money. So to take an example, if you can see on here, I know it's not the biggest chart, but there's one at 17.15 where the red line stays kind of high while the other two lines drop. So if trades were occurring at this price, somebody could do a risk-free trade and take advantage of the liquidity pool by selling at 17.15 and then buying back when it goes lower. So if you know that the market's going lower, you sell to the person who hasn't updated their price. So slow oracles create impermanent loss. Now, if you're using the purple line as your oracle, well, the impermanent loss, of course, is greatly reduced. You don't see big gaps between the purple and the white line. All right, so hopefully this convinces you that low latency is important for oracles. Now, you're probably tempted to say, well, why don't all oracles just use fast updates? It seems quite obvious. It's important. And now we're going to get into some of the economics of why that's not necessarily possible. So in order to describe this, I'll just make 2 general statements. First off, market data, financial market data is expensive. $6.5 billion from top exchanges in 2022. And number 2, actually, all that data becomes free after 15 minutes. Very unusual market. The value is all in the timeliness of the data. After 15 minutes, you can go get the data. It's very easy to access. Go to Yahoo Finance. The data is freely there. At that point, it's easy for distribution. However, when it's close to time of 0, it's very, very valuable. So you can actually write a little function that shows you this is a representation of the value. So values at T0 decays over time, and by T15 minutes, it's free. All right, so now when you go to a website like CoinGecko, as I mentioned before, or Yahoo Finance, you're probably seeing market data that starts at around 60 seconds and updates every 30 seconds. So the data is probably somewhere between 60 to 90 seconds old. The reason for this is that they go upstream, they get the data from the APIs, they aggregate it together, they filter out exceptions, calculate averages, and they publish their website. In the world for real world assets, so that was crypto, for real world assets like futures or equities, this is even more pronounced. As I mentioned, that market data is only free after 15 minutes. You actually have to wait 15 minutes before it even gets published for you to look at. Now, the first generation of oracles took all of their data from third-party aggregators. So basically, you have to wait till it becomes free or basically publicly available. And then they rely on a node to go fetch the data from the websites. And then they have those nodes form their own consensus to make sure that no one is misreporting what that website said, and then republish it. So they take data that's 90 seconds old already, and then they add further delays. I'll show you a diagram of what this looks like. And you can see here how downstream this network is. In fact, the first generation of Oracle networks only really consists of those last two columns. It's the node runners and the aggregation. They're really very far downstream, and they're getting data from third-party aggregators only. The originators of data, traders and exchanges, are not taken into account here. Now, I'm told that a lot of people are nervous because much of this stuff happens in a black box. You're only told that the node runner is getting this. You're never told where the sources are. And so perhaps for the very first time, we were able to expose how this actually works, how a legacy Oracle network works. Is riveting. The black box being exposed here. It's fascinating stuff. And you can see here, I urge you not to take any pictures. This is very sensitive breakthrough. Okay. All right, so Pyth was able to solve for speed without compromising on trust, based on three innovations. So the first one was Pyth data comes directly from the source, cut out all that excess, all those excess hops. The second one is Pyth aggregates the fastest block times in the world. So we're looking at basically physics fast for 400 millisecond block times using a distributed consensus mechanism. And number three, Pyth data outputs all come with confidence intervals. This is something that allows Pyth to publish more often because each one of the prices has enriched data, and it doesn't need to wait for there to be a global consensus, because there's not necessarily always a global consensus on, say, the price of Bitcoin. Sometimes the price of Bitcoin on Binance will differ from the price of Bitcoin on Upbit for a variety of reasons. Confidence intervals allows Pyth to be a universal price that accounts for this dispersion in the confidence interval. It could say that the price of Bitcoin is 42,300 plus or minus $100. So here is a diagram of the Pyth network. And likewise, we're able to get behind the scenes real images of the Pyth network in action. There it is. All right, comparing them again. So you can see this is the same set, right? You've got traders and exchanges. Those are the ones that fundamentally create market data, right? They are the creators of market data. Market data is the prices that traders want to trade with one another at, and the executions that just occurred. That's it. It's all financial market data is. And so you can see here that there's no third-party aggregators, no node runners that are in the middle getting in the way of being able to publish this fast. Now, I wanted to be able to show this from an economics perspective. And from an economics perspective, we can use an analogy from the music industry. So you can see here, I've got Spotify and Napster, very, very similar economic models outlined. So in the Napster model, the assumption was you can bootstrap getting music on digital platforms by having people who went out and bought CDs, burning them, and then making them available. Now, anybody who was really familiar with the record industry at the time realized that was unsustainable. If your business model is predicated on taking something for free and destroying the economic value of it, well, then people are no longer going to make music. It would destroy the industry. It wouldn't work. In fact, Napster had a series of lawsuits and was effectively put out of business. That business model really died. The Spotify model was an innovative way to be participatory for both bands and record labels, such that you're able to distribute this music to billions of people and have participation. So there's an economic creator involvement in the value. And so this is what Pyth does, right? So it has these creators, the traders and exchange, the creators of market data. They're in the network and they're contributing directly. It's not like they're cut out and it's being siphoned off from third parties. And the creator network of Pyth, the market data creator network, is huge. There are about 100 institutions, which I've gone over yesterday. It includes pretty much every large trading firm and most of the exchanges. Okay, cool. Let's talk a little bit about monetization for market data in general. So financial market data, as I mentioned, is a very valuable business. And this summarizes the revenues from the top 6 exchanges for real-time financial market data. And it accounts for 20% of their revenue, $6.5 billion. Now, you might wonder how that actually gets processed. So it's generally broken into 3 tiers of access. There's general, enriched, and customized. And exchanges sell subscriptions based on these categories. And if you have a login and API credentials for that category, you'll get access to that data. So let me go through the 3 examples very quickly. So in general, it's the simplest form of data. It's the top of book pricing, perhaps has a small delay to it. The fees are relatively low in the number of users, but then the user distribution is quite high. A good example of this would be the fee that Robinhood pays to an exchange so that their users are able to trade on the platform. So you probably didn't know this if you use any of the US retail brokers, Robinhood, Schwab, E-Trade, or any of the others, but there's a fee for all the end users that accounts for the market data costs. Of course, it's just absorbed into the bundle that Robinhood charges, and gives you real-time access. So you look at the Robinhood interface and you see the markets moving in real time, and you get some sense of where the prices of things are. Now, one step up from that is enriched data, and enriched data is something that usually human traders at professional trading firms like hedge funds, Millennium D, Shaw, Marshall Wace here is what I put down. They'll have some sort of a trading desk, and the trader will want to engage in the order book. So they'll want to see more depth. They'll want to have less time reduced market data. They want to be more higher liveness. And so they'll end up paying a little bit more for it. So I say the fees are a bit higher there, and then the number of users is a bit lower. And then finally, there's customized. I write customized because this is where things become the most extremely expensive, but there's very few users who tend to operate in this space. You can think about high frequency trading firms as being the core ones that are looking for the most optimized market data access. And basically it becomes table stakes to be able to get the lowest tier latency market data possible, because it's a highly competitive environment, and the stakes tend to be very high. Okay, so let's see how this translates to Web3. So the first thing that, from first principles, you basically ask the question, why is the market data in Web2 or TradFi so valuable to exchanges? Well, one of the reasons it's valuable is because you can do something with the data. It's actionable. You see an order at price X, you can hit it. There's some value at risk at price X. Now, that's exactly how blockchain applications use Oracle data. The Oracle updates allow for the transfer of something of value. So I'm going to take it in an exercise and try and understand how important oracles are to blockchains. And to start, we're going to subdivide, as you see here, subdivide DeFi into 2 categories: trading on one side and yield on the other. And we'll draw a spectrum of applications in that category that use an oracle versus those that don't. So on the one hand, you've got yield products, classic borrow lending, Aave compound. Now, these require constant calculations of collateral, on deposit to determine the health of the borrow, those obviously will need an oracle. Now, on the other end of the spectrum, you have yield from staking protocols like Lido, which rely on state data only to generate yield, and they actually don't require an oracle. Now, on the trading side of things, oracle-based exchanges like on-chain derivatives, synthetics, and others require an oracle for a variety of functions, from either the collateral management, the actual execution, or perhaps even just the funding rate and settlements. On the other hand, you've got auction protocols like AMMs or even on-chain order books that just rely on state data. How much is in the book at any given point? Now, it would be very mature or premature to make a prediction about how this will look in the future. I think we would all agree that things are still quite early within DeFi. There are not that many users compared to the number of users that have access to, say, the general internet. And we all probably expect that to grow. But the best we can do for now is to look at how this has evolved over the last few years in the emergence of DeFi. So here we are. We're going to take two time snapshots. So we've got June 2021, June 2023, and we're going to look how things have changed. Now, I will tell you, there's two different metrics for determining market share in these different categories. For lending, the market share is most appropriately represented by the total value locked, right? That's the total value of loans that are basically in the market. For trading, it's the total volume traded, how much volume is going on. That's the more important metric. So we'll take a look at what we refer to as market share for an Oracle-dependent product over time of these two snapshots. So in June of 2021, you had lending protocols were fully Oracle-dependent, right? It was just borrow lending with Aave and Compound being the primary ones. There's very little bit going on that didn't use an Oracle. Cut to June 2023, it's come down, and still a little bit over half is in the lending front, but we've seen an emergence of Ethereum staking with on-chain yield being distributed as taking a larger percentage now, and it is sort of becoming an emerging field. Cut to the trading side of things. Back in June 2021, there was nothing that for an Oracle to do for trading on-chain. It was just really AMMs. Now, that is totally flipped. In June 23, you've seen almost 3/4 or more than 3/4 of the market for decentralized trading on-chain using an Oracle in some sort. And so you can see that there's different things at play, but oracles have become very important, and that may change over time. Now let's talk about how blockchain oracles can monetize. So I'm going to give you a refresher. PythNet is an application-specific blockchain. All publishers publish to PythNet, and additionally, all updates are available to all the chains that Pyth is connected to. There are 400 symbols. They update 400 milliseconds, available on 45 different blockchains. Now, of course, if the updates were made to generic L1, it would be like selling a single subscription of market data for everyone to use. So the business model needs to change from subscriptions, like in Web 2 or in finance, or traditional finance, to based on transactions. Now, luckily, you can achieve similar characteristics to monetizing data in the off-chain world using subscriptions, using transactions for on-chain applications. So every transaction on PythNet gets delivered to a different blockchain. There's a fee that's associated with it that somebody pays for it. Let's look at how segmentation could potentially work in a way that's similar to TradFi. So you could hit these similar 3 tiers. There's general, enriched, customized. General, you'd envision something that is being used for, say, DEXs and has perhaps the lowest fee. Enriched, this could be something that is maybe harder to source or a different type of data that is going to be available to a certain set of users. An example I gave here could be Entropy, perhaps has a higher fee. And then there's an idea around creating things that are customized, perhaps for the largest opportunity sets within DeFi. We've seen things built out that are specific to designing, say, the block space for the most profitable on-chain transactions. Flashbots has done a great job with this. And you can envision something like bespoke auctions or bespoke pricing and rebates being done on-chain to give you these same three types of categories. Now, it's worth noting that the number of daily Pyth Network fees today is just a placeholder fee. It's next to zero. But it is also worth noting that the number of fee-paying transaction trajectory looks like this. So there's over 3.5 million updates every single day being sent from Pyth to other blockchains, all paying a tiny fee currently. And so if anything, I would say that this is potentially an encouraging sign that there's an appetite out there for this type of business model. All right, that's everything. Thanks so much for listening, and thanks for the time.